Morning to everyone. My name is HCM Swami, professor in civil engineering and also working as a consultant for structural engineering and construction. Now today's topic is structures and their feasibility in construction. So first I want to define what is a structure is. Structure is an assembly of members connected together to transfer the load freely to the ground. The structure what we are going to design should withstand all the forces which are acting on the structure. For example, the loads are dead load or environmental load or load due to any other sources. So structure should be enabled to handle the loads comfortably without destroying its utilization purpose. So structure should be planned in such a fashion that it should be economical, it should be feasible, and it should be durable. So why the structure should be designed economically? So economy means it is a cost benefit ratio. How much benefit we are obtained from the investment of money in the structure. That is called cost benefit ratio. So how much amount of money we are going to invest, that should be benefited by its utilization. How to do that? For example, if we construct a structure for a residential house and if we are using for an office complex, it is not a cost benefit type of utilization. But nowadays, because of urbanization of the country, even the residential complexes, residential buildings are used as a public building. But the structural performance should not be considered in this aspect. What I want to say is the feasibility of the structure is not beneficial by the cost benefit ratio. That means there may be a repair work, there may be a rehabilitation work, there may be a other kind of work which can incur in the structural stabilization. That means stability of the structure will be affected by the other effects. So what is the interest in our discussion is how the structure will be constructed and what is the purpose of the structural construction should be defined before the structure is put into use. First we are required to define what is the structure and what for the structure is used. That should be defined first and then the next should be considered. So to do this, the planning is required. So planning will be in two phases. First planning will be done by the architectural planning, second planning is done by the structural planning. Architectural planning should be proper, that means it should be beneficial, that means cost benefit ratio has to be maintained, and also the structural planning should be satisfied with the architectural planning. There also cost benefit ratio is more important. Why I am saying again and again cost benefit ratio? Means the structural element which are designed for a commercial building is different from the structure defined for a residential building. Structural benefit of the structure is depending upon the size of the structural elements. So if the structural elements are oversized, then automatically what we are going to invest in the structure and what we are going to use for the structure is of no use. So try to understand what is the utilization of the structure is most important while selecting a project type. So then faced with the design. What are the problems we are going to face in the design? So when the structure is going to be designed, first we are required to go for a site visit. In the site, we are going to have a different parameters are to be collected. For example, soil parameter, the other parameters like the availability of materials, availability of labor, availability of equipment, plenty of things are to be considered, and all these things should be satisfied. So, what are the problems faced with the design? When the designer, actually what we are doing in the limit state method also, the structure when we are going to design for a particular use, only 60% of the ultimate stress will be used for the structural design. That means the utilization of the load by the structure is only 60% of the what is ultimate load the structure has been designed. So again we are multiplying the initial load by a factor of safety 1.5. So again there is another margin of 50%. So total structure will be stable, but even in that condition also, nowadays the structures are under problem, under destruction, under collapse. What is the reason for this? That has to be defined now. So all these things should be defined under a heading called structural feasibility in construction. So when you are going to design a bridge or you are going to design a flyover, so the purpose we know, but the feasibility of the structural component will not be committed into picture, or they are not considered in the design. So the most important factors are different aspects of design philosophies has to be utilized and has to be established properly. So the contractor's views, the designer's views and the engineer view who is taking in charge in the site should coincide with each other. So it is not happening in the structural feasibility, because engineer who is in charge will be following the designer given structural drawing, and the contractor is casting or the contractor is constructing the structure by using the engineer given sizes. So designer should be design the structure properly. For example, I am saying a depth of beam, maximum depth of the beam in the structural design is 450 mm or 45 centimeter. But nowadays the beam designs will go for more than 90 centimeter, 1 meter beams are also available in the structural components. So we are required to know what type of structure we are going to do and what is the feasibility of the structural construction, structural design should be defined. So safety in design. So when the design safety is obtained, then feasibility of the structure should be attained. So feasibility of the design means what type of design philosophy we are using. Whether we are using a working stress, or we are using a limit state, or we are using a what you call the other method called load factor method of design. Load factor method of it is also just like a limit state method, but it's called load factor method of design. So what type of design philosophy we are using, that should be defined properly. So when we are defining the parameters, so in the limit state method, it should satisfy two conditions, strength condition and serviceability condition. In the strength condition, the structure should be able to satisfy its limit state, and in the serviceability condition, it should satisfy the deflection and the cracking. So when the feasibility of the structure come into picture, these two things should be satisfied by the structure. Cracking condition, so we are allowing the cracks from 1 mm to 2 mm in all structures other than water retaining structures, and other structures we are allowing the cracks which are up to 1 mm to 2 mm width. So feasibility will be important when the type of structure we are going to construct. So all these things should be understood properly. Then structural integration with the environment. So when the structure is constructed for a design wind load, it should satisfy the design wind load criteria. When it is designed for an earthquake load, it should satisfy the earthquake criteria. So what criteria we are going to define should be satisfied by the structural feasibility and its construction. So all these factors come into picture, and it has to be done in such a fashion that the structure should be able to withstand the all design loads under a conditioned limit state. Thank you very much.